So my name is Ashley Green. I'm a research engineer at the Department of Historical Studies and the Swedish Rock Art Archive. So I'm just going to give a quick overview of all of our visualization tools and workflows that we use for the carved rock art. So the main thing I'll be talking about is our visualization toolbox called TVT. And then I'll give an overview of what it is and the methods involved in it, and a few different applications, both for rock art and other uses that people have used the TVT for, and how we use it in our AI workflows and basically our future plans. So TVT, or Topography Visualization Toolbox, contains two separate tools to create image visualizations from 3D models and point clouds. And it was originally developed for the rock art in West Sweden, which has a very large global curvature and usually very small and very shallow carvings. And it was developed for laser scans, but now it's also working for photogrammetry models, which you'll see in a bit. But it does only work on planar surfaces at the minute. And it's available for download for Windows and Mac. So we don't claim for it to be the only tool that people can use, but of course it can be combined with the other usual sort of GIS methods. But it is a user-friendly tool that doesn't require any prior knowledge of GIS or coding like Python. And you also don't need to pre-prepare or export DEMs if you wanted to do a local relief model. And it's designed for batch processing, so you can put in a folder of 10 models at once and just wait for it to run. It's written in Python, both the user interface and the functions are written in Python, and it's open source and available on SHFA's GitHub. Sorry, I forgot to put the link there. So you input a folder of models or point clouds, and you basically get an export of 16 different images, plus some scale bars for the color visualizations. So for example, you can see the color bar for the depth map here. And your output is grouped into 4 different types of visualization. So you have your main ones that are basically the basis for the enhanced versions that a lot of people will use. You have your depth map, your texture map, your normal map, and the derivative map. And then the depth map is used to create a topographic map. And we have that at 2 different levels. So you have your object level and your texture level, depending on if you're more interested in the background texture of the rock or if you're interested in the motifs. And we produce those using 2 different filter sizes, basically. And they're produced in color and grayscale. But then we use the topo maps to create an localized enhanced visualization for the enhanced topo maps. And then we have the blended maps, which is sort of an in-between between the topo map and the enhanced topo map. So depending on the depth of your features, the size of your model, whether or not it's a laser scan or SFM data, you might want to choose a few of these different visualizations. So I mentioned previously that both the GUI and the functions are written in Python, and they all use open source libraries. So it relies very heavily on Open3D, especially for the mesh and model processing. And then all of the image processing is done in things like scikit-learn and Pillow and Matplotlib and scikit-image. And the GUI at the minute is still very simple. It's based off of Tkinter, but we've made it look a bit more modern with custom Tkinter and things like that, and added in a few tooltips so it's a bit easier for people to use without any prior knowledge. So what does it actually do? You input a folder containing meshes or point data. So we recommend users group all of their SFM models together and then separately group their laser scans together and then point clouds, because they often requires some scaling for the SFM models because it was originally developed for laser scans. But we have 2 different tools. If you use the mesh tool, TopoViz, the meshes get pre-processed to extract the vertices. Whereas if you're using point viz tool, obviously the vertices are already there, so we skip that step. And then there's some cleaning and scaling and rotation, and then the user decides whether or not they want to perform these steps, or if they just want to leave it to auto cleaning. And then the data that's remaining get interpolated to a gridded image. And then from there, we generate the depth map, normal map, texture map, and create the topo map, which is similar to a local relief model, but more like a difference map because we're not taking the contours. And then we do the image enhancement with contrast, localized, adapted histogram equalization. Sorry. And then we create a blended image, which is a mix between texture map and the enhanced topo map. And then everything gets saved in color and grayscale. So we can see a few examples. We have an SFM model of Tonum 89-1, so near Gothenburg-ish. And we have, starting in the top row, you have your depth maps, your texture map, and your topo map. And then you have your normal map, your derivative map, and the grayscale topo map in the bottom. And you can see sort of from this, there needs to be a bit more enhancement done. So we can take a look at the other level of topo map in the first column. So this would be the object level. And then you have your blended maps in the last two columns. So again, object level and texture level in color and grayscale. And you can see in the last column that we can start seeing more of the features and carvings that we're interested in. So we can zoom in even further to the visualizations that most users tend to go with. You have the 4 different enhanced topo maps. You have your texture level on the left and your object level on the right. And you can see, perhaps on the small screen, that there are more carvings coming out in the enhanced version. So I'll zoom in even closer for you. Yeah. So we'll take a small section of the panel. You have your ortho photo on the top, and then you have the enhanced topo object level on the top right, enhanced texture level, and then the blended color version, just so you can see a difference between the color version and the grayscale. Most people tend to go for the grayscale because the color can be quite strong. But we'll take a look at 2 examples. So you have one ship here, which I do promise is an ortho photo, but I've highlighted it for you. And you can just see that more features start to pop out. But you can also start to get some shadowing in the enhanced version. So some people do tend to go for the blended version. And we'll also take a look at the human figure, which is there. You can sort of see its legs. But again, we bring that out a bit more. And like I said, this is obviously, we're not claiming this to be the only tool you should use, but it does work well when combined with the usual local relief model workflows within GIS environments, if you want. And then we can take a shift from rock art, just to demonstrate that it doesn't have to only be used for rock art. We have an example of a halberd, and you might have guessed that this was quite difficult for them to take the model of. But again, you have your depth map, your texture maps, your normal maps, and the usual topo maps. And then you have the more enhanced visualization, so the blended maps at the top and the enhanced maps at the bottom. And then we'll take a closer look. So we can see in the ortho photo, kind of, that there's a misalignment in the rib and some hafting lines down the bottom. But that becomes a bit more clear in the enhanced visualizations and the blended visualizations. Shifting back to rock art, one of the main points to create these visualization tools was for the AI, which I'll talk about in a bit, but it's also integrated into SHFA's website to make it easier for both researchers and the public to actually see the carvings, because as you've seen previously, if the carvings aren't ones that they paint in, for example, all the ones in the World Heritage Area are painted in, then it's quite difficult just to see from a photo, especially depending on the lighting conditions at the time. So all of these visualizations go into SHFA's website, and we now have a 3D model viewer using grids. You've heard a few people from Grid. They're a multimodal viewer, which is based off of 3D Hop. And so we have the model viewer, and then alongside that, you have all of these visualizations. So you can flick through and compare the visualizations to the original model and zoom into points and then share specific motifs, links to specific motifs, if you like. And then if we take an example of someone from outside of SHFA using TVT, another person from Grid, researcher from Grid, has used the tool to generate visualizations of the inscriptions in St. Sophia Cathedral in Kiev. But I provide this example because they, unlike a lot of other users, have used the texture maps instead of these enhanced visualizations. And the texture maps, you can sort of see, still work kind of well for them. And it's provided a basis to do all of their annotations of the inscriptions. So shifting a bit towards why we developed a tool to begin with. So we've had a range of pilot studies, investigations on AI tools. So we've gone from the very basic object detection with faster RCNN around 2020. More recently, which I'll show more examples of coming up, I've switched to oriented bounding boxes because we do have such long figures, so we'll end up with long boats or tall humans, and the bounding boxes for those aren't quite localized if you use the normal bounding boxes. And we've also gone into a bit more detail with semantic segmentation. You can kind of see that it gets a bit difficult, and I've been a bit tricky here and shown an example of the segmentation where we have types of motifs. So we have animals here that are kind of underrepresented in our data set. So performance on that isn't the best. But the outcome of these has basically been that in types of motifs where there's a lot of variability, so we have humans, which can look quite different, and we have animals, which can look quite different because animals includes things from birds to horses to deer to moose. Those classes are quite difficult to detect, but examples that we have a lot of, like ships, that works really well, and cut marks also worked really well because there's very little variability in cut marks and quite a lot of them. But for now, we're focusing on the oriented bounding boxes and going a step further with polygon annotations for those bounding boxes. So I showed the example just a second ago of our oriented bounding box detection, and you can also see how TVT works on laser scans here. These are both laser scans. So I trained a yellow 11M, fine-tuned a yellow 11M model for 75 epochs with early stopping. So it ended up being around 60 on both models. So we trained a binary model. Is it rock art? Is it not rock art? And then we trained a multi-class model, which includes everything from humans, animals, weapons, wheeled transport, which is usually wagons, and everything basically but cut marks because we have so many of them. And we can see still the classes that we have a lot of data for are detected quite well. So we can still get most of the human in because that's a common human shape. It's really good at boats. It was surprisingly good at detecting the lures, but again, there's a bit more consistency, even though we only have a few examples. But we can, when we zoom into the animals, we can see that it often misses the antlers from the deer and the elk because we don't have as many examples of those because a lot of our data comes from West Sweden. So at the minute, we're planning to integrate more binary detection with the polygons so that we can then use the legacy data combined with the extracted polygons here because there is obviously more tracings. There's more variability in the labels that are available in the tracings and things like that. So that was a bit quick, sorry. Where we're focusing next, the AI tool will be integrated into TVT. So those visualizations with the oriented bounding boxes I just showed, the inferencing tool for that will be integrated in TVT next week. Unfortunately, I wanted to release the Mac and the Windows versions at the same time. So we'll be continuing training as we go on. This is an ongoing process within the SHFA. And I mentioned at the beginning that right now TVT only works for planar surfaces. So we're doing automatic sectioning so that users don't have to clip their models beforehand. And one thing that's been requested quite frequently was exporting georeferenced images. So that'll be available in the next version as well as making it a bit faster and adding in the GPU support because everything runs off of CPU now. And then I mentioned a few issues with AI models that we have now. So we'll be working with larger data sets, including those tracings and things like that, and also including data from outside of Sweden, and just cleaning up the labels that are in there and switching to polygon labels as well. Yeah. And just to acknowledge that a lot of the laser scans that went into the training were generated by Henrik Zedig at Länsstyrelsen, and the original work for this was part of projects funded by RJ and Vetenskapsrådet. Thank you.
Showing us a bit of magic when figures just popping up on the screen. Have you found a lot of new figures on the rocks?
Yes, so there were quite a few new ones found when the first project ended in 2021. They found quite a few new ones, and ones that aren't painted in, so that adds to the interpretation of that. Yeah. Especially smaller features and shallower features. So there's quite a few smaller anthropomorphic figures, especially in the panels around West Sweden, that are now discovered.
Yes. And now let's see if we have anyone in the audience. Yes, we have a question in the back. Och medan du fixar med micken så påminner jag om att du ska presentera dig först.
Precis, jag försökte. Thomas Hageus. You said it only works for flat objects. How flat do they need to be? And is it, for example, if you have a round column with inscriptions, could you unroll it first and then unroll it in other software?
Yeah, so that's what we do now. We basically unroll it, or if you have, say, SFM of like the inside of a tower or something, then you would split that into two. What you want to do, it does work if you have rounded edges, but because you're stretching the color scale across those rounded edges, it comes out more enhanced. Features are more visible if you flatten it a bit. So yeah, you can either unwrap it or split it into several different models at the minute. Yeah.
Och vi har en fråga online. No? Björn has a question. Okay. It's hard when the chat moderator also wants to ask questions.
Björn Schummer, Riksantikvarieämbetet. I like the way that you approached the open source nature of development for the tools used, and I also particularly like that you collaborated with Grid. How has the process been working with open source solutions and the development phase of the tools that you use here? And do you see a strong foundation to build further and include also other institutions, other agencies, etc., for foreseeable future?
Yes, hopefully. We aim, especially with funding requirements, obviously, we aim for everything to be open source and usable. And that collaboration with obviously more technical research infrastructures and groups is quite beneficial to us. Yeah.
And another question.
Hi, Agnieszka Backman. I was wondering how easy is it to use the tool? Do I need to know Python to actually use it, or is it clicking?
It's literally just plug and play.
Awesome.
And I'm sort of collecting user feedback now just to make sure like the tooltips do offer what they're supposed to, but there are tooltips on each field, basically. Yeah.
And now we have a question online. Really cool initiative. Is there an intent with the open data for other technologies to be connected to the toolbox in the future?
Yes. Short answer, yes. Long answer, it is in development for things like SEM. We want to integrate that and other sorts of input data. We have shifted a bit towards developing more GIS toolboxes as well. But of course, when those are developed, we can also duplicate those tools in TVT. Yeah.